A vast, world-class NASA manufacturing complex is the Machute Assembly Facility, MAF, near New Orleans East, Louisiana.
Check the tolerances on that seam right there.
Already noted. Looks within spec, but we'll double check.
Alignment looks good. Move forward 5 centimeters.
Copy that. Moving now.
Inside the core factory, the assembly of the massive rocket demands absolute precision. Engineers meticulously inspect every component.
Check the tolerance on section 4. Looks good, well within limits.
We need to double check the alignment on engine 3 before the next sequence.
All right, let's review the schematics.
We are ahead of schedule on the nozzle integration.
Good. Let's review the fluidic thrust vectoring system next.
The Space Launch System core stage stands as the largest rocket component ever built, a testament to precision engineering.
The core stage, seen here emerging from the factory, represents years of dedicated work and the future of deep space exploration. This is the core stage of the Space Launch System, the most powerful rocket ever built. The core stage leaves the assembly facility, beginning its journey down the historic waterway. Using the Pegasus barge, the core stage is transported to Stennis Space Center, which takes a couple of days.
And fire. The hot fire test ensures reliability. Then, the cryogenic testing process verifies the systems before the and dying. This static fire test is crucial for the Space Launch System, ensuring the booster's performance before integration.
We need to verify the depth of this pattern before moving it to assembly.
I already checked the first 5. They are consistent.
The massive isogrid panels are crucial for rocket lightness and robustness, requiring precision engineering and advanced CNC technology.
From these massive halls, we are forging the future of aerospace, combining human expertise with state-of-the-art machinery.
All right, bringing her down now. Easy does it.
Copy. Descending slowly. All clear on my side.
Control, bring it down 5 degrees.
Copy that. Lowering now. Keep an eye on the starboard cradle.
Engineers adjust the FSBS to allow them to add several sections together to produce the full rocket.
We are clear for final approach. Speed very slow.
Roger. Checking tolerances now. All right, bring it down slowly. Watch the alignment on the far side. Looks good from here. Keep coming down easy. Clear to set.
The isogrid structure is crucial for maintaining the balance between lightness and robustness in our space rockets.
Steady on the left.
All right, easy now, bring it around.
Watch the clearance.
Check the alignment on the isogrid. Tension looks high.
Copy. Adjusting the hoist rate now. Keep it steady, bring it down slowly. Copy that, watching the port side. All right, easy now. Watch the clearance on the starboard side. Copy that, moving slowly.
Okay, bring it left 5 degrees.
Copy that, moving left.
Watch the clearance on the clearance.
From the massive assembly hall to the intricate clean rooms, building the next generation of rockets requires absolute focus.
Watch your clearance on Bay 3. Easy now.
Steady as she goes, driver. We are clear.
Measuring over 50 feet long, the ICPS stage is carefully transported to the high bay, where it will be integrated. The heart of the rocket, the core stage, is assembled here in the VAB. Engineers and technicians.
We need that torque checked on the lower bulkhead. Roger that. Bringing the lift around. Absolutely magnificent.
The core stage, secured and ready for rollout. A critical step before integration at the launch pad.
Keep it steady. We are clear on the left side.
Confirmed. Proceed slowly.
Transporting the core stage requires precision. Once inside the factory, our engineers begin the meticulous assembly.
We have alignment on the bolts, slow and steady.
Clear on level 3. Set her down gently.
Lowering sequence initiated. Maintain tension on the lines.
Ropes are steady, Capcom.
Clear to proceed.
Artemis 1, NASA's first integrated test flight of the SLS rocket and Orion spacecraft, was a great success.
Solid rocket boosters provide the primary thrust for the initial stage of the launch.
The future of space exploration begins here, at the Inside Core facility.
The Promontory, Utah site is crucial for the U.S. space program, developing the solid rocket motors that power our exploration. Alignment looks good. Continue rotation to Station 4.
Copy. Initiating sequence.
We have 3 more units coming down the line this week.
Good. We need to clear space for the next fuselage segment.
Keep it steady on the flatbed.
Roger that. We are clear for the next rotation. Okay, the booster segment is approaching the alignment mark.
Copy that. Trajectory looks nominal. Keep monitoring hydraulics.
These segments are lowered into propellant pits, where propellant is cast into the top and allowed to cure.
Copy that. Trajectory stable.
We are still go for launch. Mark the time at 0400 Zulu.
Clear the area below. We're bringing the tank section down.
All personnel accounted for. You are clear to proceed.
Ensure the coating is uniform across the ribs.
Copy that. Moving to the next section now.
Check the pressure valves. Okay, bring it up slowly on your side.
Copy that. Watching the clearance.
Looks good. Set it down gently.
Rotation looks stable at 50 RPM.
Confirming thermal readings are within tolerance.
Crane operator, we are clear for rotation to the south wall.
Copy that. Moving slowly.
Roger that. Coming down slowly on cradle 4.
Copy, we are clear on this side. Keep it steady.
Lower the payload.
Watch the clearance. Hold it there. We are clear for final insertion.
The torque on connector 42 is holding steady.
Good. Check the thermal sensors next.
This represents the culmination of a critical collaboration. Northrop Grumman and ULA working together on the future of heavy lift.
The sturdy test stand grips the booster horizontally for a 90-second firing.
The sheer power on display here at the Inside Core factory is critical to validating the booster's performance.
All right, easy now. Bring it up steady. Watch the clearance on the starboard side. Keep it coming up.
This massive facility in Decatur, Alabama, is where United Launch Alliance is building the future of space exploration. The massive VMC begins the precise work of shaping the rocket structure, a critical step in the manufacturing process.
This section here, it needs a final wipe down.
Already on it. The surface finish is critical before transport.
Inside core factory, in this case an orthogrid, also simply referred to as a ribbed or stiffened structure, is used instead of an isogrid.
To curve the aluminum sheets, massive industrial presses are used to curve the sheets without damaging them. Chemical milling allows us to precisely remove material from large components like these rocket panels.
Here we see the specialized treatment process, ensuring the metallic panels can withstand the rigors of space.
Bring it down another 2 inches, easy now. Watch the clearance on the left side. Holding steady, coming down slowly.
Check the alignment on section 4.
Looks good from here.
Clear for transport.
Inside this facility, the largest rockets ever constructed are meticulously assembled.
This tolerance is tighter than the last spec.
Yes, we need to adjust the feed rate accordingly.
How's the alignment looking back there?
Dead center, boss. Moving at 2 meters per minute.
How does the overlap look on section 4?
Looks good, right on tolerance.
Make sure the overlap is exactly 3 inches on that seam.
Got it, just finishing the tape here.
We need to verify the torque settings on this coupling point.
Looks within tolerance from here, but let's double check the logs.
Clear the yellow line, moving through Sector 4.
All clear. Continue to the next waypoint.
Confirming rotation sequence Alpha 9.
Received. Sequence initiated. Maintain 1 RPM.
Several booster rockets with their fuel tanks are needed for a launch, depending on the type of launch vehicle. The assembly of these massive booster rockets and their fuel tanks requires an unprecedented level of precision engineering and human oversight.
Lowering the sheet now. Watch your clearance on the left. Looks good here. Bring it down another foot.
The massive payload fairing dominates the core factory floor. Here, precision engineering and collaborative effort.
The automated weld looks stable at Sector 7.
Agreed. The heat signature is nominal.
Maintain rotation speed at 0.4. Copy that. Speed is stable. Welding looks good from here. All clear on the ramp.
Roger, maintaining 2 miles per hour.
Watch the clearance on the starboard side.
The booster fuel tanks travel by truck to the rocket ship docked here on the Mississippi River, bound for Cape Canaveral or Vandenberg, Illinois. These massive booster tanks, transported by truck to the Mississippi River, begin their journey by ship to Cape.
All right, moving into the main bay now. Keep the pressure steady.
Confirm, Cap. Looks clear up ahead.
Clear the bay. We are moving the core stage.
Copy that. Watching the clearance on the left.
Watch the clearance on the starboard side.
Looks good. Coming up on the rail alignment point now.
All right, maintain slow speed, approaching the lift point.
Copy that. Tensioning the slings now. Clear below.
Roger, beginning the rotation to vertical.
All clear on the starboard side.
Copy that. Proceeding with the lift. Tension is good.
Watch the clearance on the tower. All teams report green for integration.
Roger that. Proceeding with the final descent.
Watch your spacing on level 3.
Check the alignment on the lower bolts.
Looks good from here, making the final checks now.
The sheer scale of the core stage demands absolute precision.
Ensure the alignment is within tolerance.
Confirmed, everything is nominal.
Confirmed trajectory is clear for gantry alignment.
Roger that. Proceeding slowly.